Hello everyone, welcome to our Python script tutorial series. In today's lesson, we'll dive into a topic of data structure transformation. We'll kick things off by introducing a powerful Python library called pandas, which is incredibly useful for data management. Our main focus will be on providing various examples of raw data formats and showing you how to translate them into a data frame and save them as a CSV file. So let's get started. If you already have a CSV format file, that's great. You can use the built-in pandas method called readCSV to improve your data. So let's see how it's done. So what's the magic behind the CSV file? Well, let's explore another way to import our file using the Realines method. When using Realines, Python will not pre-process the data, but it will show the original format. As you can see, a CSV file is called a comma separate value file because all the data inside is separated by comma. Our next step in this journey is to transform data in various formats into a standard CSV format. So this will enable us to work with the data efficiently and perform various operations on it. Let's proceed with opening the file popular baby name space and use the realines function to read the file. Store its content in the variable lines. It reveals that this dataset contains approximately 57k rows. In your list, data start from index 0. This will be the first row. If you want to access the last row, you might think using length lines as the index will work. But remember that this starts at index 0. That's why you'll encounter the error. So, to access the last row, you need to use the length lines -1. So this is the last row. Alternatively, you can use -1 to print the last row. So you can see, both approaches will yield the same output. Now, if you wish to print a range of rows in a list, you can use the format start number, colon, end number. Please note that the number needs to correspond to the rows you want to print, and you need to add 1 to the end number. So now it's printing from row 0 to row 9. Let's explore how to assign data into a data frame. In a data frame, each column should be presented as a list. Our data should be in an array format, which the element inside the array is corresponding to a row. Our objective is to extract the header and transform our data into a list of lists, a format suitable for data frame. Let's see lines again. The first row serves as a column name, while the rows below contains the actual content. We can utilize the split method to divide the string into a list. For instance, consider a sentence. This is a sentence separated by space. And in sentence, space acts as a separator, indicating that everywhere where there's a space, the string is divided. So when you use the split, we can split into a list. If your data has a different separator, you can adapt the split method accordingly. For example, if your sentence is another sentence with apple, comma, banana, comma, cat, you can specify the separator as a comma for splitting. The data we're working with is separated by space. To set the first row as our column names, we select data at index 0 and split it using the default space separator, and this will form the columns of our data frame. Let's address the content. We know that the content is stored in an array format. To handle this, we'll split the content element by element and using a method called append to construct multiple lists into an array. To illustrate, we will start by assigning A into an empty list, then we'll add the A1, A2, and A3 with the following data. So next, we use the append to append A1 into A. So this is current A, and again, we append A2 into A. So this is the update A. Let's repeat the process. We assign the content to an empty list. Then we will use a for loop that starts from the line 1 to its end. As we know that line 0 contains the column name, we'll iterate through every line from line 1 to end and utilize the split function to break the data into a list, which will then append the content to list. and we obtain an array. Now, let's assign the color name and the content to a data frame. So by doing this, you get a structured data frame. That's great. Now, let's encapsulate the script into a function. But what exactly is a function? Think of function as a preview tool that stores a specific set of actions for you to use easily in future. Create a function, start with def, means define, followed by the function name, and any parameter you want to include. In this case, we want to pass the raw data as a parameter called lines. Then simply add the script we just wrote inside the function. Once the script is complete, we will use the return to provide a complete data frame as the output. Now, let's put the concept into practice. Doesn't this make the process more transparent and efficient? That's about all of today's tutorial. We will explore more type of the raw data in next session.